Hello, in the last video we looked at arithmetic sequences and common difference. So let's start off with just a review. So we've got 2, 4. What do you suppose would come next in this sequence? If you said 6, that would be reasonable, and 8 and 10, that would be reasonable. And you would know, these dots mean it can keep going. You would know that the common difference is 2 because 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2, and so on. So there we go. Let's contrast that to this. 2, 4, 8, 16, 32. What's going on in that one that's a little bit different than the first one? Is it still a sequence? Remember, the definition for a sequence is just a ordered list of numbers that form some sort of pattern. And if it is a sequence, is it an arithmetic sequence, or is there some other kind of identifiable pattern there? So hopefully you're recognizing that you are just doubling the previous term to get the next term. So a geometric sequence involves repeated multiplication. In this case, we're timesing by 2. So let's put ace of 1, ace of 2, ace of 3, ace of 4, ace of 5, like that. And to determine if a sequence is a geometric sequence, it's kind of similar to determining if a sequence is arithmetic. We take ace of 4, instead of subtract this time, it's a ratio, over ace of 3. And is that equal to ace of 3 over ace of 2? And is that equal to ace of 2 over ace of 1? Let's see what we've got. So 16 over 8, 16 over 8, and then 8 over 4, and then 4 over 2. And if you look at those ratios, they indeed are proportional to each other. There's a proportion there. And if you simplified them all, it all equals 2. And so the common, this time it's not the common difference, it's the common ratio. The common ratio is 2. So in a geometric sequence, we work with the common ratios instead of common differences. We do a division. Let's practice one. This one's kind of a fun one. 125, 180, blank, blank, blank. Could you find the common ratio in this sequence, and then extend the sequence 3 more terms? Okay, hopefully you've had enough time to look at that. If this was the third term and the second term and the first term, let's go ace of 3 minus ace of 2. I'm sorry, I'm doing that wrong. I'm doing it as if it were arithmetic. Ace of 3 divided by ace of 2, third term over second term, and ace of 2 over ace of 1. Let's see if these, the big question is, are they equal there? Are they equal? So we've got 80 over 100, and then we've got 100 over 125, like that. And if you put these in the calculator, you end up getting 0.8. 0.8 there, and 0.8 there. So now that we know that they are equal, we also know the common ratio. The common ratio is 0.8. So let's times 80 by 0.8. Let's times it by 0.8. And we get 64. And if you want the next one, let's times 64 by 0.8. I can't do that one in my head. 48 and 3 is 51. You get 51.2. And so on and so on. So this is an example of a geometric ratio. It's kind of interesting. In this one, we're multiplying by a number that is less than 1. The ratio is less than 1. So our numbers are getting smaller and smaller and smaller instead of bigger. And they're getting smaller at a slower rate. So that's an example of a geometric sequence with a common ratio of 0.8. Over here we had a geometric sequence with a common ratio of 2. The big idea behind geometric sequences is that it involves repeated multiplication, and you would need to know how to recognize if a sequence is geometric by using this little formula here and determining if they have common ratios. You'd have to figure out the common ratio, and then you would have to extend a few terms out based on your common ratio, a few terms out in that sequence. So that's kind of sums things up for arithmetic sequences, and then on this video for geometric sequences. Thank you.